Okay, so the lesson today for exponents is division using exponents. So last class we looked at the product rule or the product law. If you had the same base and the bases are being multiplied, then you would add the exponents. And today the quotient rule, if you have the same base and they're being divided, then you're going to subtract the exponents. All right, so that's called the quotient property rule or the quotient law. So the rule tells us to subtract the exponents when dividing numbers or variables that have the same base. You're going to keep the base the same, and you're just going to subtract the exponents. So as shown here, we have x to the power of a divided by x to the power of b. So when we simplify that, we keep our x as the base, and we're going to subtract a minus b for the exponent. All right, so let's take a look at some examples here. So our first example, we have 8 to the power of 12 divided by 8 to the power of 3. So our law states that we are going to subtract our exponents if the bases are the same and they're being divided. So first step here I'm just going to show is we're going to take our 8 is our base, and we're going to subtract 12 minus 3. Right? And that becomes 8 to the power of 9. Okay, so like we're working with numbers here, we can further put this into standard form, but we're going to leave our answers in exponential form. So we're just going to leave it as 8 to the power of 9. Right, next example, we have x to the power of 15 divided by x to the power of 12. So we keep our base as x, and we are going to subtract 15 minus 12 for our exponent, and that becomes x to the power of 3. All right, our next example, we have x to the power of 6 multiplied by y to the power of 5, and it's being divided by x to the power of 4 times y to the power of 2. All right, so one other way I do prefer to write these is to show division this method. All right, so this is the other method. You can write division. Now you can clearly see how they're being divided. So we got x to the power of 6 minus 4, and then y to the power of 5 minus 2. So that becomes x squared y cubed as our final answer there. So this is example number 4. So what I'm going to do with this example is I'm just going to rewrite it out the other way. I'm just showing it rewritten like this. All right, so now I have my A's lined up, the B's are lined up, the C's are lined up. All right, so when we're doing this, keep in mind when you have negative exponents. So we're still subtracting the negative exponent. So for example, here, when we have our base A, it's 3 minus negative 2. And then for B, it is negative 4 minus 2. And for C, it's 4 minus 2. All right, so that becomes a to the power 3 minus negative 2, which is a to the power of 5. And then for B, I have negative 4 minus 2, which becomes the negative 6. And then for C, it's 4 minus 2, which is 2. All right, so that is the simplified answer. A to the power of 5, B to the power of negative 6, and C squared. All right, so for our next example, we have the 21 over 24, which we can reduce. Both the numerator and denominator can be reduced to 7 over 8. Good. Okay, so next we have x, and it is to the power of 3 minus 4. And then we have y to the power of 7 minus 3. And then we have z to the power of 2 minus 1. All right, remember this z here, it still has a power of 1, even though it's not shown there. All right, so just continuing that, we end up with 7 over 8, x to the power of negative 1, y to the power of 4, and then z to the power of 1, or just z. Okay, so our next slide here we have x to the power of 6 divided by x. So you guys remember that it is x to the power of 1, so it becomes x to the power of 6 minus 1, which gives me x to the power of 5. All right, good job catching that one there. Okay, next we have x to the power of negative 7 divided by x to the power of 14. So x to the power of negative 7 minus 14. Okay, so you are using like integers here. So make sure you are subtracting and make sure you are putting in the correct signs for the numbers. So negative 7 minus 14, that becomes x to the power of negative 21. All right, if you had put 1 over x to the power of 21, that is okay as well, but like I said, for now you can leave it with negative exponents. Okay, here we have 18 x8y5 divided by 6 x to the power of 6y cubed. So we do have to work with our numbers here as well. So 18 over 6 can just be divided to 3. So we end up with 3. And then we have x, 8 minus 6, which is 2. And then y, we have 5 minus 3, which is also 2. So we end up with 3x squared y squared. All right, so this example that we have here, we're going to have to use our product law and then the quotient law. So looking at our numerator here, we have x to the power of 7 times x to the power of 3 times x to the power of negative 5. So we do add those using our product law. So it's 7 plus 3 plus the negative 5. And then our denominator, same thing, we have x to the power of 6 times x to the power of negative 5. So we have x to the power of 6 plus negative 5. All right, so then we would continue to simplify that. So we get here 7 plus 3 plus the negative 5 gives me x to the power of 5. And then here for a denominator, 6 plus negative 5, which gives me x to the power of 1. Now we can use our quotient law, where we would subtract our exponents. So x to the power of 5 minus 1, which becomes, I'll just put it down here, which becomes x to the power of 4. All right, so our next question here, we do have to use the product law and the quotient law. So our numerator, we have a to the power of 4 as well as a to the power of negative 7, and the numerator is all being multiplied. So we're going to use our product law there first. So for a, we would have 4 plus negative 7. And then for b, we have 3 plus 14. All right, and then our denominator, we can't collect anything there, so I'm just going to leave it as is. All right, so that gives me a to the power of negative 3 and b to the power of 17. And for our denominator, we have a to the power of 1, b to the power 10. Now we can go ahead and use the quotient law and subtract. So here we have negative 3 minus 1. I'll just write that out. So negative 3 minus 1, and then for b, we have 17 minus 10. All right, so our final answer here, negative 3 minus 1, that gives me a to the power of negative 4, and then b to the power of 7. So this here is the final answer.